All right, section 9.7, similarity transformations. We went over on Friday that transformations can be congruent and similar, but similar and not necessarily congruent. A similarity transformation is a transformation in which an image has the same shape and not necessarily the same size. We wrote on Friday that similarity transformations include a translation, which is a slide, a reflection, which is what's a reflection? Flip. Rotation is a turn, and a dilation reduces or enlarges the figure. Two figures are similar if and only if one figure can be mapped onto the other through one or more similarity transformations. So the two that we did Friday, we did example A when we realized that the two triangles were a reflection of each other across the line y equals 4. To be a reflection, we're noticing that the points are the same distance away, so H and H prime are the same distance away. So the rule was a capital R for reflection. We had y equals 4, and then the shape that received the reflection. For example 2, we noted that it was a dilation. Looking at the m to m prime, it was getting smaller. After we wrote down the coordinate pairs, we realized that it was reducing by half. So there's a capital D there with a subscript half to represent the scale factor, and it happened to the shape JKLM. I'm pretty sure my afternoon classes finished C, but we're going to do it anyway. So determine whether the two figures are similar using similarity transformations. If similar, describe the transformations used, and if not, explain why. Do they look similar? What two transformations do we think are happening? So there's a translation, and there's a dilation. To get the size of the dilation, instead of looking at the ordered pairs, let's look at the side lengths. We can count that from A to B, there's 4 units, and from C to D, there are 4 units. AC is a little bit trickier because it's slanted, but we can use the distance formula, which is rise squared plus run squared, all under the square root. So from C up to A, how many is it rising? 4? Yeah? 4. So 4 squared, how many is it running? 1, 2, 3, 4. 1, 2, 3. So 4 squared is 16. 3 squared is 9. Added together?
Oh, just kidding. I only went to 6.
So the square root of 25 is 5. Same length over here. We can do the same thing for EF. We can count that there are 2 spaces and 2 spaces for GH. And I'm going to use distance formula again to find the slant of G to E. So it's rising 1, 2, and running 1.5. So 2 squared is 4. 1.5 squared is, I believe, 2 1/4. Added together, we get 6 1/4. And the square root should be, got it, 2.5, thank you. Look at the side lengths. What do you think the dilation is? To get from the one on the left to get down to the one over here on the right. It's being dilated by half. So I'm going to say, where do I have some space? I'm going to say capital D half to A, B, C, D. Let's do that. Let's take all of these ordered pairs and cut everything in half. So A is at 1, 6. So where is A prime going to be? Cut it in half. 1/2, 1, 2, 3. I'm going to call it A prime. B is over here at 5, 6. So cut it in half. 2.53. C is at -2, +2. So cut it in half. 1. Wait, half of 2 is 1. All right, so there's C prime. And then D is at 2, 2, so 1, 1. Let me use a different color. So we're looking at this shape, A prime, B prime, C prime, right in there. So now it looks like it's the same size as E, F, H, G. Now we have to worry about translating it. So look at A prime and look at E because they do correspond. When we deal with a translation, this is your X value and your Y value. So your left, right, and then your up, down. So A to E prime, what we have to go to the right? How many units? Yep. And then what direction are we going once I go 2 to the right? 1, 2, 3. So a -3. So this is kind of messy. Let's write these rules a little bit neater. So our final answer, we did a dilation of 1/2 to A, B, C, D, and we translated 2 to the right, 3 down, A prime, B prime, C prime, D prime. First period, do you have any questions? All right, go ahead, take a peek at letter D, and then we'll resume the video. To finish up example D, what we looked at is the ordered pairs. We found that point A was -10, 10. It is counting by 2s. That point C was -8, +2, and that point B was -4, +4. Using Pythagorean theorem, which again is rise squared over run squared, we found that the length of AC was 8.24. Then we ended up finding that the length of ZY was 4.12, and we recognized that they were being dilated by a factor of 1/2. We went ahead and found the length of CB just to be thorough, and it ended up giving us the square root of 20, which was 4.47. And the square root of, or I'm sorry, the length of YZ was the square root of 5, which was 2.23. So we realized that it was being dilated by a factor of 1/2. And this is triangle ABC. Take a moment and reduce all of those points that we found by that factor of 1/2. So 2, 4, 2, 4, 5. So A prime is here, B prime is here, and C prime is here. Once we have it dilated, I say we, I'm talking about first period and I, noticed that the triangle is being reflected across the y-axis because between B prime and X, they're the exact same distance as they are from C to Y. So we reflected across the y-axis triangle A prime, B prime, C prime. 2 more examples. These ones are worked out for you, but I would like to take a moment to explain them. What we did for letter E was we counted the side lengths of the rectangles and found that KJ was 6 and that ON was 3, so dilated, cut in half. KJ was 8 and OL was 4, so cut in half again. So looking back at it, realizing that from the 6 to the 3 was cut in half, and from the 8 to the 4 was cut in half. But what I would like to do for all of them is to talk about translations from left to right. So instead of being cut in half, it's really being dilated by a factor of 2. Take a second and plot the dilation. So if we take L and multiply it by a factor of 2, it lands perfectly at G. N lands perfectly at J. So this was only a single transformation. It was a dilation to show that the two are similar. Lastly, for letter F, I know you don't have this one. Draw it if you'd like, but at least listen. We have 2 rectangles, and I found that the lengths of the long sides were 7 and the lengths of the short sides were 4. Then for the one down there in yellow, the side lengths ended up being 4 for the long and short for, or the 2s have a length, the shorts have a length of 2. So these two are not similar because the side lengths are not proportional. If we're talking about a length of 2 over 4, also equals 2 over 4, so that's half. But 7 over 4, because it does not yield 1/2, they do not have a similarity ratio. The homework tonight is the front side of the orange worksheet. It's called section 9.7, Similarity Transformations, and the quiz corrections will now be due on Wednesday. Please make sure to do the Google form, and the URL is at the top of the correction sheet. Thank you.